Let's look at this Oxford interview question given f of exponential x plus 1 divided by exponential x minus 1 equals x. But this is actually a hidden symmetrical problem. But by the end of this video, you'll be able to see why the answer is a natural logarithm in disguise. So yeah, this is a mathematical function, right? So and what I will tell you is you must be very calm, because most students panic when they see exponential x inside the given particular function. So let's see the solution. So for this particular function, so we'll be using substitution method, and the first step we are going to take is to let this whole exponential x plus 1 divided by exponential x minus 1 to be t. So we have exponential x plus 1 divided by exponential x minus 1 equals t. So from here, what we're going to do next is to solve for x in terms of t. But before we let's solve for t, all right, so let's solve for exponential x, and to do that, let's exponential x be equals m. So therefore we are going to have m plus 1 divided by m minus 1 equals t. So this appeared to be a long approach, but to use the short approach, let's cross multiply here. So we are going to have exponential x plus 1 multiplied by exponential x. I'm talking about this. Multiply by, we have 1 here, so multiply by 1 equals t multiplied by exponential x minus 1. So we have to expand this, but this will become exponential x plus 1 equals t exponential x minus t. So now, since our goal is to first solve for exponential x, right? So let's collect the like term. So we have 1 plus t, all right, equals t exponential x. Let's transfer this to the other side. So we have minus exponential x. So then we have 1 plus t equals, we have exponential x in common. Let's factorize that out. We have exponential x. What is left here? We have t minus, what is left here? 1. All right. So now what we are going to do here is to divide both sides by t minus 1, coefficient of exponential x. Since we are solving for exponential x, we have t minus 1, t minus 1. So we are going to have exponential x equals t plus 1 divided by t minus 1. So if you look at this is what we have, but how do we solve for x? So then the best way to do that is to introduce natural log, or let's say ln to both sides. So because m is to power x will be what? Will be x, because ln n ln exponential x equals x, right? What I'm trying to say in essence here is that majorly natural log is used to find the exponent, so when the exponent is unknown, right? So now if you introduce natural logarithm to both sides of this, we have ln exponential x equals ln t plus 1 divided by t minus 1. All right, now you should not you should know that the length of something is a function of, let's say z. So i.e., if you have function of z now, so this is equal to ln z. All right, so let's move forward. So therefore, if a equals b, then ln a is equals to lane B. All right, so therefore from this above expression we know this lane will cancel this exponential, so therefore we have x to be equals lane t plus 1 divided by t minus 1. So you see that the expression we have here is in terms of t. Therefore, in terms of t, we have f of t equals lane t plus 1 divided by t minus 1. This is our f of t. That means we have the function in terms of t, but we are asked to find f of x. So that means that we are going to, the function we are going to get will be in terms of x. All right. So, however, let's recall that we let our exponential x plus 1 divided by exponential x minus 1 equals t. Let's remember this. So if you have this, we have to just, what we are going to do now is to just replace t to be x in the above expression. So therefore we have f of x equals lane. All right, so we've let this to be our exponential x plus 1, that means our t. Therefore we have x plus 1 divided by x minus 1. Guys, this is our final answer. However, you can use other methods, so I'm going to try to use another method now, so we are going to see which one is shorter and which one is the most convenient. So before I solve this using the second method, so you can also drop your other ideas or method in the comment section, so I look forward to receiving them. So however, in this method we are going to consider the other idea or method, so and which is the domain of the function, so to solve this. So in the first scenario, x could be anything, you understand, so and it could be 0, because if we have exponential 0, so this is going to be 1. All right, and when we have 1 minus 1, I mean here, this will also be 0. Therefore we will have this condition that says x plus 1 divided by x minus 1 is greater than 0, right? So, and if you have it like this, we can easily solve it by making the table here with 3 rows. Let's say we have the first line, we have the second line, and we have the third line. So we have the other line here, we have another one here, then we have another one here. So this will be x plus 1, and we have x minus 1 here. The other factor we have here is this divided by this, and that is x plus 1 divided by x plus 1 divided by x minus 1. All right, so here we have minus 1 and we have 1 here. So what we are going to have here is 0. All right, so and we are going to have what here? We are going to have 0 here. So here now we have minus, here we have plus, here we have plus. All right, so then here, I hope you understand. So and here we have plus as well. So it's just about like performing a basic arithmetic here. So here we have minus and here we have plus. For this, just divide this by this. We are going to have plus, we are going to have minus, we are going to have plus here. So